everyone, this is Miss Byrd. Welcome. So today we are going to be adding and subtracting polynomials. Go ahead and write down that title. And you don't have to write down these two anchor charts that I have here, but I do want to go over them. So adding and subtracting polynomials. The first thing we're going to talk about is a monomial. So a monomial is a variable, a constant, or a product of variables or constants. What that means is it's one term, okay? So if you look here on the right, it says monomial 3xy to the second power. This is a monomial because it's one term. It is actually a product of variables and constants. You see how there's multiplication happening between a constant and variables. A binomial is the sum of two monomials, okay? So here a binomial, you'll see that there's subtraction. Anytime you see addition or subtraction, it's going to separate the terms. And here we have two of them. You can see that this is a binomial because we have one term here, and this is the other term, okay? And then we have what's called a trinomial. A trinomial is the sum of three monomials. So here you can see that they're being separated with addition and here subtraction. So we have one term here. Here we have a second term, and this is the third term, okay? Okay, so that is the definition of monomials, and all of them are polynomials, okay? So a polynomial can be with one term, like the monomial. This is considered a polynomial, and this is also considered a polynomial. So all of them are called polynomials, but when it's one term, it's monomial, two terms, binomial, and so forth, okay? Okay, straight from the book, it says on page 338, so if you ever have to go back to your book for notes, it gives you the definition of a monomial. So a monomial is a number variable or the product of a number and one or more variables with whole number exponents. And the degree of a monomial is the sum of the exponents. Okay, so that's really important, the sum of the exponents, okay, of the variables in the monomial. The degree of a non-zero constant is 0. For example, if you have the number 5, the degree here would be 0, okay? Now, they're saying the constant 0, so let's say you have a 0, that does not have a degree, okay? So let me show you some examples of what that means. Okay, so let's look at some monomials first, and then what's not a monomial, okay? So we're going to make a little chart, and we're going to say these are monomials. And then we're going to figure out what the degree of each one is, okay? Okay, so the first example is the constant 10. Well, we said earlier that if we have a non-zero constant, then the degree is 0. So the degree for a number by itself is 0. Unless it's 0, if this is a 0, then there's no degree. Another example, if we have 3x, you can tell that this is a monomial as well. And the degree here is you want to look at the exponent of the variable only, okay? So the exponent of the variable is an invisible 1, so the degree is 1. Then we have this example. Let's say we have 1/2 a b to the second power. Okay, we want to find out what is the degree of this monomial. Now, the degree of a monomial is the sum of the exponents. Here we have an invisible 1. We have the exponent of 2, and so you have to add the two exponents. So our degree is actually 3. Let's look at another example. Let's say we have negative 1.8 m to the 5th power. Well, our degree here is 5 because our exponent is 5 right here. Okay, so this is a little table of how to find the degrees of the monomials. Okay, let's take a look at what are not monomials. Okay, so this is not a monomial. And then we're going to talk about the reason. Okay, so this is not a monomial. For example, 5 plus x. And the reason why it's not a monomial is because a sum, remember, anytime you have addition or subtraction, then it's not a monomial. So right here we're going to put a sum is not a monomial. Oops. Oh, there we go. Sorry about that. Okay, the next example is a fraction 2 over n. Okay, that's a variable n as in Nancy. Okay, so this is not a monomial. And the reason why it's not a monomial is because we have the variable in the denominator. So here, anytime you divide by a variable, it's not a monomial, okay? So here we're going to say variable is in the denominator. Okay. The next example is 4 to the a power. Now, the reason why this is not a monomial is because we have a variable as an exponent. So the reason, variable as an exponent. And then one of the last examples is x to the negative 1 power. Now, the reason why this is not a monomial is because the variable must have a whole number exponent, okay? And right now it's an integer. So here we're going to write variable must have whole number exponents. Okay. Let's look at some examples. I'm going to go to the next page. Okay, so the directions say find the degree of each monomial. Okay, example number 1. Negative 3x to the 4th power. Okay, so here we have to find out the degree. You look at the variable and the exponent. Since there's only one variable, it's only this one, so the degree is 4. Okay. Number 2, 7c to the 3rd power, d to the 2nd power. Okay, so here, to find the degree, you're going to look at the variables, right? So we have 3 and we have a 2. You have to find the sum. So the answer is the degree is 5. Okay, number 3. Five-thirds y. Okay, you look at the variable, the invisible number here, and our answer is 1. Number 4. Negative 20.5. Okay, so what's the rule if you have a constant? If you have a number, the degree is 0. Okay, let's look at the next part. Okay, so now we're going to talk about types of polynomials, which were introduced at the beginning. So here we're going to say type. We're going to make a table, okay? So type of polynomial. Okay, we're going to look at an example of how that looks. We're going to see it in standard form. And then we're going to list what the degree is. Okay. Okay, so the first type is a monomial. So an example of that would be, let's say negative 3z to the 4th power. So this is a monomial. To write it in standard form means we're going to put them in order by the degree and the leading coefficient. So here the degree is 4 and it's actually only one term, so you just keep it as is. And the degree here is 4. Okay, the next type is a binomial. So an example of that is 8q plus q to the 5th power. Okay, so we're going to put it in standard form. Now, in order for it to be in standard form, we have to make sure that the degrees are in order from greatest to least. So here I see a 1, and then here I see a 5. So the degree of each variable, we're going to put them in order from greatest to least. That means that q to the 5th would be first, and then 8q would be next. So this is in standard form. And then we're going to find out what is the degree. So here in this case, remember with monomials, you find the sum, but here you have a binomial. So the rule is a little bit different. The degree depends on the leading coefficient or the leading term. Here, the leading term is q to the 5th. So the degree of this term is the degree of the whole polynomial. So here we're going to say 5. Okay, and then the last type is a trinomial. So an example of that would be 4 plus 5x to the 2nd power minus x. So we're going to put these in order. We're going to put it in standard form. So we're going to look at the variables. Here I have x to the 2nd power and x to the 1st power. So the greatest one is this 2, so that's going to go first. So it's 5x to the 2nd power. Next is going to be minus x. And then the constant always goes last. That's always at the end, okay? Now we want to find out what is the degree of this whole polynomial. Well, you just only look at the first term, and here we have x to the second power, so the degree is 2. Okay, so what we found out here was this. Let's say we have this polynomial. I'm just going to write it out. This is just an example. Let's say I have 2x to the third power plus x squared minus 5x plus 12. We need to know what each part is, okay? Okay, the 2 right here in the front, this is your leading coefficient. So if it asks you of this polynomial, what's your leading coefficient? You would say 2. On this example up here, what's the leading coefficient? You would say 5. Up here, what's the leading coefficient? The invisible 1, so you would say 1, okay? So your leading coefficient is the number that's squished together with a variable, and it's from the first term, right? Because since this has the biggest exponent, it goes first. The 3, of course, this is going to be the degree of the whole polynomial. And then at the very end right here, this is the constant, which is the number. Okay, let's see some examples here. Number 5, the directions say write the polynomial in standard form, identify the degree and leading coefficient of the polynomial, then classify the polynomial by the number of terms. So there's several things that we're doing here. Okay, so the given says, this is number 5 from the book, 4 minus 9z. Okay, the directions first say write the polynomial in standard form. Okay, so remember that the constant is always at the end. So the negative 9z has to go first. So we're going to write that first. Negative 9z plus 4. Okay, so there we wrote it in standard form. The directions then say identify the degree and leading coefficient. Okay, so what's the degree here? Well, you're going to look at your answer, and the degree is the exponent of the leading coefficient, well, the first term, and it's invisible 1, so we're going to say 1. That's our degree. Then it's asking you for the leading coefficient. The leading coefficient is the number in front of z, and here it is the negative 9. So we're going to say negative 9. And then it asks you to classify the polynomial. So there's 2 terms. So because there's 2 terms, this is called a binomial. Okay, so the directions, they asked you to write it in standard form. So that's the first answer. Then they wanted to know the degree, and then the leading coefficient, and then classify the polynomial. Okay. Number 6, the given says t to the second power. I usually don't write my t's with the curve, but I do it with math because I don't want it to get confused with the plus sign. So t to the second power minus t to the third power minus 10t. Okay, so the directions say first put it in standard form. So let's do that. Okay, so which one do you think would go first? So the negative t to the third power goes first. Next would be t to the second. So it's a positive, so we're going to say plus t to the second. And then the last one is going to be minus 10t. Okay. Okay, so the next answer is what's the degree of the whole polynomial? 3. Next, what's the leading coefficient? Right here in front, -1. And then we have to classify it. What is the name of this polynomial? 1, 2, there's 3 terms. So we're going to say it's called a trinomial. Okay, number 7. 2.8 x plus x to the 3rd power. Okay, let's put it in standard form. So that means x to the 3rd goes first, plus 2.8x. There we go. Next, what's the degree? The degree is here in front, so it's a 3. What's our leading coefficient? Right here, it's invisible, 1. And then what is this called? Let's classify it. There's 2 terms, so it is a binomial. Very good. Okay, let's go to the next part. Okay, I'm going to show you how to add and subtract polynomials. So this part, we're going to call it adding and subtracting polynomials. Okay, so we're going to continue. This is number 8. So we have here 6x plus 15 plus 8x minus 3. Okay, so let me show you how to do this. Remember that whenever you're adding, you want to add your like terms. So I can see here that I have 6x and 8x. Those are like terms. So I'm going to go ahead and combine those two. So when I combine it, I get 14x. And then I look at my constants. I have 15 and I have minus 3 or negative 3. And if I combine those two, I get 12. I can't simplify it anymore, so this is my final answer. Okay. Number 9. Three x to the 2nd power plus x minus 6 plus, open parentheses, x to the 2nd power plus 4x plus 10. Okay, since we're just adding straight through, I'm going to add my like terms. So I notice that I can combine 3x to the 2nd power with x to the 2nd power. So I'm going to combine those two. And I end up with 4x to the 2nd power, right? 3 plus 1. Okay, next, my next terms, so I'm done with these. Next, I can add x with 4x, and I end up with positive 5x. Okay, and then the last part are my constants. Negative 6 plus 10 gives me positive 4. And there's nothing else to combine or simplify, so we are done. This is the answer. I'm adding my polynomials. Okay, let's move on to number 10. For n plus 5 minus negative 2n plus 4. Okay, so this one's a little different because now we have a subtraction. So we're actually subtracting the polynomials. Okay, so what we're going to do with this subtraction is we're going to distribute it into the second polynomial. So I'm going to distribute like this. So I'm going to keep the 4n plus 5, bring it straight down. And then I'm going to distribute. So that means negative times negative is positive 2n. And then a negative times positive is negative 4. So there, I distributed the negative. Okay, so now we're going to combine our like terms. So I notice here I have 4n, and I can combine it with 2n. So 4 plus 2 is 6. So I have 6n. And then I'm going to take care of the constants. The constants, I have 5 minus 4, which gives me 1. I can't simplify it anymore, so this is it. My answer is 6n plus 1. Okay. The next one I want to go over is number 11. I have 4x to the second power minus 3x plus 5, close parentheses, right? Minus, open parentheses, 3x squared minus x minus 8. Okay, so here we're going to leave the first polynomial alone, and I'm going to distribute this negative into the second polynomial. And there's 3 terms, so it has to be distributed into all 3. Okay, so I'm just going to bring this first one down. So here, negative times 3x squared is negative 3x squared. And negative times negative is positive, and then negative times negative is positive. There we go. Now we can combine our like terms. Okay, so I'm going to look at my 4x squared first with negative 3x squared. When I combine those two, I end up with x squared, and it's positive. So this one's gone. Okay, so next I'm going to look at my negative 3x squared, combine it with x, negative 3x, not squared. Negative 3x with x, and when you combine those, you get negative 2x. And then my constants that are left over, 5 plus 8 gives you 13. Is there anything else to simplify? Nope, this is it. Okay. So my answer is x squared minus 2x plus 13. Okay, let's go over the last problem, the last example here. Number 12. 4d minus 6d to the third power plus 3d to the second power minus, open parentheses, 10d to the third power plus 7d minus 2. Okay. So since we are subtracting the two polynomials, I'm going to distribute the negative into each term. Okay, so I'm just going to bring the first part down. Okay, a negative times 10d to the third is negative 10d to the third. Negative times 7d is negative 7d. And then a negative times negative is positive. Okay, now let's combine our like terms. So I already know I have to put it in standard form, so I'm going to look for the highest degree of each term. So I noticed the third power is going to be the highest. So I'm going to look at this first. So negative 6d to the third power. I'm going to combine it with the other d to the third power. So negative 6 plus a negative 10 gives us negative 16d to the third power. So the next coefficient is 3d to the second power. I don't see any others, so I'm just going to bring it straight down. And then next I have 4d right here and negative 7d. So 4 minus 7 is negative 3d. And then my constant that's left over is plus 2. And then you want to double check, can I simplify anything else here? Did I skip anything? Nope. So then this is it. This is our final answer. Okay. All right, that's it. This is Miss Byrd. Thank you for tuning in.